Welcome back. All right, so today we're covering 4.4. This is proving triangles are congruent. The last time we worked on this, we were in section 4.3, and we had to have all the different pieces of the triangles being congruent before we were able to say that the individual triangles were congruent. Well, this time we're going to use just tiny pieces of the triangle to get the whole thing's congruent. Before we do that, though, we need to define this word, the included angle. The included angle is the angle of the triangle formed by two sides. The included angle is the angle that's in your triangle that's formed by two sides. It looks like this. I have a triangle. I have a highlighter. Oh, I've got two sides. The included angle then would be this angle right in here that gets created when you sweep from one side to the next side. That's the included angle, and so that's one of the ones that we're going to be focusing on today.
Even though it's the included angle is that one in the middle, could it also be like a base angle?
Yeah, it could be any of them. It's just when you're talking included angle, you have to look at two sides, and whichever angle's between the two sides that you're looking at, that's the included angle.
Oh, so like, let's say...
So I could turn it this way, and that would still be the included angle.
Oh.
Yeah, okay. Great clarification, thank you. Last time we were together, in the previous episode, we said that two triangles are congruent if the corresponding sides and the corresponding angles are congruent to each other. But that was a lot of work to show all the sides and all the angles congruent. And so we want a faster way to do it. The side-side-side postulate is the first fastest way that we have. To shortcut it, again, we can abbreviate now. We're going to do SSS postulate. Side, side, side. This postulate allows you to show that two triangles are congruent while only needing to show that the three sides, the three pairs of sides, are congruent between the two triangles. Here's what the postulate actually says. It says, if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. And your setup is going to end up looking something like this. I've got two triangles. I have one pair of congruent sides. I have another pair of congruent sides. I have a third pair of congruent sides. The triangles are congruent.
So it's just one of those postulates of like common sense, right?
Yeah, this is one of those, we're just going to trust you. Because it's a postulate. We're not going to try to prove it. We're just going to go, okay, boss. Let's use the side-side-side postulate in a proof. Because we are proving that triangles are congruent, we have to go back to our proofs. And we're going to do some two-column proofs. We'll end the day with a paragraph proof. In our paragraph proof, we are given that line segment AB and line segment DB are congruent. Here is line segment AB, here is line segment DB, and them are congruent. The next thing that we're given is that C is the midpoint of line segment AD. Here is line segment AD, and here is point C, the midpoint. Looking at our proof, the very first statement always has the reason given. So if we look at our given statement, it's going to be some of that stuff. But if we look further down our statements of our partially completed proof, we see part of our given already written. Which part's already written?
C is the midpoint of AD, which is another given.
Yep. So what's the other part that I have to write?
Line segment AB is congruent to line segment DB.
There it is. I'm going to go ahead and fill in the reason for statement 2 as this was given. Now the next reason that's shown on my partially completed proof is the midpoint theorem. So this proof wants us to use the midpoint theorem for something. Looking at our given, we're told that C is a midpoint. And C is the midpoint of this line segment AD. What does that mean?
AC is equivalent to CD, which is congruent.
Because C is the midpoint, it means that point is in the very center of that line segment. When something's in the very center, the two pieces on either side of the center are the same size. They're congruent.
So a midpoint can be a bisector?
It is. A midpoint is indeed, can be considered a bisector. Yes. And so we can write that statement. The next thing I notice in my partially completed proof is that it tells me that line segment BC is congruent to line segment BC. Okay. Line segment BC is congruent to line segment BC. The reflexive property. It's congruent to itself.
So therefore, triangle ABC is equivalent to ABD. DBC.
Let me just, I guess, kind of tweak what you had stated. You stated triangle ABC is equivalent to triangle DBC. And I'd like you to instead use congruent, because these two triangles are completely different triangles. They just happen to be the same size and the same shape. Whereas when you use the word equivalent, it means they're the exact same thing. And they're not the same triangles. They just are the same size and the same shape.
Like shoes.
Like shoes. Yeah. Except the shoes aren't equivalent because I couldn't put the right shoe on my left foot. Even though they're the same size and the same shape. Yeah? Okay. Quick vote while you finish out writing your theorem. Thumbs up if your 2-column proofs feel better than they were the last time you did it. And then hold your vote. Thumb up if it's a little better than it was last time. Thumb sideways if there's absolutely no change in your 2-column proof. Thumbs down if I just made it worse. Vote now. Let me see. Okay. All right. Okay. So most of us are thumbs up. We've got a few thumbs sideways. That means there's no real change. Let's try another 2-column proof, and I really would like to focus on the ones that had no significant changes. Those few that went in the different parts of the room. And I'd like you to be the ones kind of offering things on this one, okay? All right. Here's our given information. I'm given that RS congruent to UT. Here's RS. Here's UT. I've also been given RT is congruent to US. Here's RT. Here's US. And that's all I've been given. And I'm trying to show that this triangle, RST, is congruent to this triangle, UTS. Very first statement in any proof is always going to be the given. So I'm looking at my first partially completed proof statement. And I see some stuff. So I'm just going to make sure that this stuff is what was given. That checks out. That checks out. It has everything in my given statements. So I shouldn't see any more givens anywhere else in the proof. Except I do. Oops. Look, it's not something I put together for you guys unless I've messed up somewhere, okay? Sorry. That one shouldn't be there.
Yeah.
Like,
Could it be transitive property? Because then we would do RS and equivalent.
If you can find the situation, the setup for transitive, yes. Then it could be. But if you don't have the setup for transitive, then no, it can't be. All right, let's take a look at our triangle. We have right now two ways to prove triangles are congruent. We can use the corresponding parts. That means all the different pieces of the triangles are congruent. C, P, C, T, C. Or we can use the new one from today, side, 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 where all we need is to show that the three pairs of sides are congruent. What does it look like we're the closest to setting up?
Side, side, side.
Looks like we're closest to setting up side, 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 because I've got two pairs of sides congruent. I just need the third pair. I need this side belonging to this triangle to be congruent to this side belonging to this triangle. Can I say that that side TS is congruent to that side TS?
Of
Yes.
congruence.
Because the reflexive property of congruence allows me to say a thing is congruent to itself. And even though that segment is related to two different triangles, it's still the same segment.
And that'll be line segment TS is equivalent, is congruent to line segment TS.
Perfect. Thank you for the correction mid-sentence. According to our partially completed proof, we have enough information to state our triangles are congruent. Why?
Side, side, side postulate.
The side, side, side postulate. Yes, you may abbreviate this one to SSS. You're welcome. Because we have shown that all three pairs of sides are congruent to each other.
Yes.
When you're done, head toward the second page and give me another feedback. Thumbs up. Two-column proofs are just even a little bit better than they were before. Sideways, there's been no change. Thumbs down, I made it worse. Vote, please. Miss Claire? Okay. All right, thank you very much. Looks like the few of you who had sideways thumbs the first time are now thumbs up. That means it's getting a little bit better. I'm happy. Let's add another way to prove the triangles are congruent. We have the all things are congruent, corresponding parts, CP, CTC. We have the side, 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 where all we need are three pairs of sides. Another way to show two triangles are congruent is the SAS postulate. If S stood for side in the last one, what do you think A stands for in this one?
Angle.
Angle.
Side, angle. Side.
Exactly. This postulate is formally known as the side angle side postulate, or SAS for short. This is the sassy one. The SAS postulate says this: if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then those two triangles are congruent. Your diagram is going to end up looking something like this. I got two triangles. I got a pair of congruent sides. I've got another pair of congruent sides. I have the angles that those sides are creating congruent to each other. I have the setup for side, angle, side.
Because then it forces them to be like exact numbers.
Because if I threw in numbers, it would force those things to be the same numbers. Yeah.
And so if side AB is congruent to DE, angle ABC, and E are and side BC equals are congruent to EF, then they are congruent, the triangles.
Yes. we're going to start practicing for our paragraph proof, which is our final example for today. We're going to practice that by writing out in as close to full sentences as we can our reasoning as to whether these three diagrams can be proven as true with the side angle side setup. Let's look at this first one. I have two triangles. I have these two pairs. I have this pair congruent. I have this pair congruent. And I have these two angles congruent. Do I have the setup for side angle side? I've got a yes. I've got a thinking.
No.
I've got a
Yes.
couple no's. Okay, tell me why no. Like, I know why yes, because we've got two sides and an angle. But why no?
Because angle ABC is not like in the same position as YXC.
No.
Because angle B isn't in the same position in terms of congruent as this one. This angle B is not the included angle for triangle ABC.
It's a base angle, right?
It's some other kind of angle. I don't, if it were isosceles, it would be a base angle. I wasn't told, so I don't know. But I can say that in triangle ABC, angle B is not the included angle. And without that included angle information, I can't use side angle side. Because side angle side requires there to be the included angles congruent. So far, so good?
Yes.
Yes? Make sense? Okay. I was kind of half listening to the side conversation going, yep, sounds like they're talking to each other. All right, let's look at these two triangles. I have two triangles. I have these pairs of sides congruent. I have these pairs of sides congruent. And I don't have any other angles marked congruent. But what kind of angle is this?
90 degrees.
And what kind of angle is this?
90 degrees.
They have the same measure. Angles that have the same measure are?
Congruent.
Those angles are congruent. The right angles are congruent.
And we could also use the side angle side postulate.
We've got to see if we've got enough information. It's not enough for angles to be congruent. The congruent angles have to be the included angles. Are the right angles the included angles?
Yes.
Yes.
Therefore, I can use side angle side postulate. The right angles are congruent. They're also the included angles. The three dots mean therefore. Therefore, I can use side angle side. If you're already done writing, start looking at the next diagram, please. Here's the third diagram. I've already highlighted, color-coded the things that are congruent to each other. In orange, I've got that side congruent to itself. What else do I know about these line segments, PQ and SR? They're parallel. I've got this extra little arrowhead in there telling me them are parallel. If those are parallel, what do I know about these angles 1 and 2?
They're inner. They're
Alternate interior angles. And when I have a transversal cutting parallel lines, alternate interior angles are?
congruent.
So here's our explanation paragraph proof thing. Angle 1 and angle 2 are
Congruent.
alternate interior angles. because line segment PQ is parallel to line segment SR, angle 1 is congruent to angle 2 by the alternate interior angle theorem. The two triangles are congruent by what bit of information?
Side, angle, side.
Side, angle, side postulate. Because I have side, angle, side. Two sides and the included angle congruent. I want another quick vote. When you're done writing, give me a thumbs up if paragraph proofs feel like they could be a little easier than the last time you dealt with them. Sideways if you think they're going to be about the same. Thumbs down if you're still like completely lost on paragraph proofs. Vote now and just hold it up while I take a quick look around. Okay, we've got a couple of people who are sideways and down thumbs. So what I'd like to do is our last example for today says write a paragraph proof. And so I'd like to cater this example to those of you who had thumbs sideways and down where paragraph proofs are still uncomfortable or a complete hot mess. All of you had said before we came to this page of notes that the two column proofs were feeling better. They might still be a little shaky, but at least they're feeling better and definitely better than the paragraph proofs. So I'd like to start this as a two column proof and then show you how to go from there to the paragraph proof. Okay? So you're welcome to start it as the two column. Once you feel comfortable, translate it into the paragraph proof. Okay? So let's set this up as a two column proof. The very first statement is going to be what's given. So I'm just going to write what's given, and I'm totally going to abbreviate because space, and because this isn't my final proof, you know? Because I've been asked to write a paragraph proof, not to write a two column. I'm using a two column to get me there. Okay? So this is like a rough draft. As long as I know what I'm talking about, it doesn't matter how you write it. Okay. That's all we've been given. I have this picture. And I'm told that V is the midpoint for YZ. If V is the midpoint of YZ, what's true about either side of V?
They're congruent.
Also, aren't they vertical angles? So their angles are
We're going to create some vertical angles. You're already noticing that. This one and this one.
Yeah.
And this one and this one.
So that would make that their angles are congruent as well.
All right, slow down. Let me get there. You're absolutely right. Just let me get there. All right. So now that I have this, I'm going to use my given to say V is the midpoint of WX. So what other pieces can I say are congruent?
That WV is congruent to WX. Therefore,
So that's what I'm going to write as my next statement. I use the fact that V is a midpoint along with our midpoint theorem to state that those pieces of segments on either side of V are congruent to each other. Now it had been stated that these angles in here are vertical angles.
yes.
They're vertical angles because they're angles that are created by two straight lines intersecting, and they're on opposite sides of the vertex from each other. They're non-adjacent. They're not next to each other. There's a theorem that lets us state that vertical angles are congruent.
Vertical angle theorem.
The vertical angle theorem lets me state that all vertical angles are congruent. And so the name of the theorem is my reason, and then I'm going to write the name of the vertical angles. I can't just write angle V, because then I'm going to write angle V is congruent to angle V. Which angle V are you talking about? I'm talking about the one that goes from Y through V toward W.
So then we just write
This
y
angle in
v-
here.
y v w.
And on the other side, I'm talking about this angle that starts at X, head towards V, and then goes to Z. Angle YVW is congruent to angle XVZ. Do I have enough information to say my two triangles are congruent?
Yes.
Yes, which is the statement I wanted to prove right up here, so I'm going to copy my proof statement down. And then I'm going to state the reason that I have enough information. I have side angle, side. I have two sides and the included angles, which ended up being vertical angles, and so my reason they're congruent is the side angle side postulate.
Couldn't you also use a side-side postulate? Because if those two are congruent, like, since those two have those measures, then wouldn't the bottom one have to have that same measure as the other one?
Great notice on that one. I don't have a theorem or a postulate that lets me go, if two angles are congruent, then the opposite sides are congruent in two different triangles. I have the one for isosceles, where I have if two angles in a single triangle are congruent, then the sides opposite them are congruent. But I don't have where one angle measure gives you the measure of the other. Okay. So I can't use side, side, side. I'm forced to use side angle side. Now I promised you a quick and easy way to turn this two-column proof into a paragraph proof, especially for those of you who were feeling uncomfortable with the paragraph proofs. Here's how you do this. Look at the very first statement box. Write that. I'm going to write exactly the way I wrote it in the statement box, except I'm not going to abbreviate. And I'm going to add in a couple of words here just so that it doesn't completely not make sense. All right, I wrote everything in that first statement box. I'm going to put an X through it. Because remember, I'm not being asked for the two column, I'm being asked for the paragraph. So the two column is my scrabbly, crazy notes. Once I'm done with that statement, I'm going to write the word because, and then I'm going to go to its reason box, and I'm going to write whatever is in there. And then I'm going to put a period. And then I'm going to go to my next statement. I'm going to write everything in that statement box. I'm going to write the word because. I'm going to write everything in its reason box. Period. I'm done with the second statement in reason. Real quick, I'm going to do the last two, and then we'll come back and try to clean up this paragraph proof, because we want to see what it's going to sound like when we're done writing it. And here's what my paragraph proof ends up sounding like. V is midpoint line segment YZ, and V is midpoint line segment WX because given. Because what?
Oh,
Because of the given. If you're on a test and you're pressed for time and you've been asked to do a paragraph brief and I go 5-minute warning and all you have time is to do this rough draft version, I'll take it as long as all the information is in. You should probably go back and clean it up like this or clean it up as you go. Either way. How about this? V is midpoint. V is the midpoint. V is the midpoint, line segment YZ. Of. I did that for the rest of the sentence. Line segment YV is congruent to line segment VZ, and line segment WV is congruent to line segment VX because midpoint theorem. Because of the. Angle YVW is congruent to angle XVZ because vertical angle theorem. Triangle XYZ is congruent to triangle WVY because side angle side postulate. Yeah. Now, do you want to make it feel like the last sentence is like your end? Like that's your conclusion? If you wanted to, we could add one last transition word. What kind of transition words do you have from English?
Finally.
Finally, in conclusion. Thus, therefore, so. Any of those transition words would be amazing to put right here in order to make this feel complete.
Yeah, when I wrote it down, I put thus triangle line.
You did it already. Which is great. Which is great. If you can't edit as you're creating it, don't worry about it. Do just like what we did here. Write it and then edit. If you can edit while you're going, then awesome. More power to you. That's all I had for you guys today. Thank you.